Good evening. My name is Ben Lewis. This is my lab presentation, comparison of recorded motion with simulated. So the purpose of the lab was to prove that an object with a net zero force acting upon it will experience no acceleration and will continue with its motion or lack of it. This is a reflection of Newton's first law of physics. And as seen in the diagram, only forces that should be acting on the cart are a normal force pushing up the cart from the track and a force of gravity pushing the cart into the track, as well as a constant velocity in. We will assume friction to be negligible simply because it's kind of is, but as you will see, it's not necessarily. So to do this lab, we used a 17 centimeter cart, a cart track, camera to record it, and then tracker software to analyze the video. The cart was given a brief push to create initial motion. The video records the motion, avoiding rotating or moving the camera as best we could. And then we uploaded the video to Tracker as an MP4 file. We chose the cart to be our calibration stick, so 0.17 meters. X plus was set as the left of the camera, and the cart was set as point mass A. And then I clicked the center of the cart in each frame of the video, or tried to, and observed the resultant data and graphs over here. Then, after plugging all those data points into Excel and then analyzing it, I created a quote-unquote an average initial velocity of 0.639 meters per second, which was just me averaging like the first 8 velocity data points I got from Tracker. Then wrote a loop using the position update equation, and then ran the program, and here are the results. All moves to the right, and the graph shows a positive slope. So when both data sets were compared, creates this graph wherein the orange is the simulated, so the code, and the actual, my recorded stuff, and the tracker data points is this navy line. Both closely mirror each other, especially towards the beginning. However, towards the end, there's a small difference between the two. And, that is because a little bit of friction messed with it. Anyway, cart follows the principle of Newton's first law in that the system maintained a constant velocity, only being minorly decelerated by the environment through friction with the track. Possible error for this experiment was, as seen with the vertical oscillations on the graphs, is the result of my manual clicking on trigger. And in the original video, the camera rotates by a small degree. We cropped the video enough to where it didn't affect it that much, but it's just a minor thing to consider. And then the what if question they asked us to is whether or not if we swapped the x with a negative x, it does not change the magnitude of v, it only changes the direction. So when you plug a negative v into the program, the ball goes to the left this time, and the graph is with a negative slope. Thank you for your time.